I'm José Antônia. I work in the TV arena. I've been working a long time with TV production. And in my area, there is a movement that converges toward networks, IP networks. Not in the distribution area that has existed for a long period of time. I'm not talking about media distribution from the web, but here within the studio, within production, live production of TV. I participate of the Brazilian Society of Engineering, and we created like 2 years ago a study group to see this new movement that we're observing in the world, that is the production movement. So this movement has gained momentum, or it gained momentum when high resolution like 4K, 8K started emerging. The equipment within the studio, from black and white, analog, digital era, standard resolution, then after in HD TV, these equipments were always connected to coaxial cables for video, audio cables. We're talking about a specific cables for this type of connection. Now, when the first 4K camera emerged that has a resolution and a beat rate four times higher, it was necessary to evolve here. Because the first cameras, as they had 4 times more resolution, they needed 4 coaxial connections. And all of this within a production environment, within a studio with hundreds or thousands of interconnected pieces of equipment, this would be impossible to carry out. Now, in the case of the 4K, that has rates 4 times higher, so it's like 6 gigabits to capture 30 frames or 12 gigabits per second in a capture of 60 frames per second. It was developed. There are channels that have boards with SDI connections. We still have this type of connection in 12 giga, but working with coaxial cables at distances that are not very long. Here we have distance limitations, and unidirectional signals is still a problem within production. Here we have the rates that are used today for HD TV, 1080p. That is what we see in the open TV. Or cable TV, the rate is 1.8 gigabits per second if it's 30 frames. And in the case of 4K resolution, where we already have production and displays of 4K TVs in some countries of the world, they already have open broadcast at 4K. The rates would be around, for production, 12 gigabytes or 24 gigas. And 8K, we already have networks broadcasting 8K. That would be like Japan, that was already in a race to broadcast 8K until the Olympics. These rates are even higher. But although we have all these SDIs at 12 gigas, we cannot jump out of the race because we would need hundreds of videos for one connection, fiber connection. And why IP within the production? Because it gives us a dynamic workflow. We will talk about this later on. As you only have one connection, it is very easy to share the resources, to broadcast remotely. and also IP, because with format you can go to HD TV, you can evolve to 4K, 8K. It's an agnostic format and it's not blocked as it is today in SDI. Of course, we have a reduction of cables, a reduction of weight. When you think about a mobile unit that is like the cart to carry out major events like carnival, football, you diminish the amount of infrastructure that is needed inside one of these vehicles. And this is also important in the studio. And in addition to this, you are also part of the IT world with all the innovations at the scale of the IT market. How is an interconnection inside a studio today? Here you have a number of sources or transmitters of image. Here you have cameras, microphone, you have the control tables, the special effects, you have visualization, and everything in the SDI world would use coaxial cable, audio cables, synchrony cables. Every source should start with the same pixel, the same point, the same line, so that we can work in unison to have special effects amongst the different sources. And everything in the SDI world is interconnected through an SDI matrix that would be cross points, and are in charge of the interconnection between the source and the destination. So basically, this is the type of installation that we have in the SDI world. What we intend to do here is to have an interconnection with less cables, or only cables and fibers, using Ethernet amongst all the transmitters and receptors of the network. This using an internal screen. Most of the networks that are using, or TV networks that are using these type of installations, carry out this type of network. It is a simplified network, and they use two networks here. Everything that is in one network is totally copied to another network. The idea here is not to increase the traffic velocity, but yes, to have the redundancy of this traffic. You will have independent networks, and one can stop. You can work with one network, update it, while the other one is still working, because it would be very difficult to have a live schedule. You cannot stop your network for 10 minutes. So what we do here is each source has two outputs, and we use a protocol to use 2022 transducet, and the receiver can receive these two signals and switch when there is a drop. But the idea here is to have a non-drop network. As I already mentioned, the space gain that we have when we install this is something very significant. And here we have a comparison between one installation with SDI, and here on the other hand we have another installation with only 10 units. Another characteristic that allows us to work with IP is the flexibility, because here you can distribute resources, or you can optimize. Remote production is using by TV networks that use IP. Why? Because with this, you will only have one data center where most of the equipment are placed. This is control, effect, graphics, and at remote distances, you can capture the images, therefore you distribute your team. The team that captures the image can be located in different places, or they can be traveling in different cities. For instance, in a worldwide championship or a national championship, this is used a lot in Australia. The capturing team goes to the stadiums and cities, and they're connected to a central station where the transmission or the broadcast is controlled. Here, resource sharing is very important and interesting with these type of installations or facilities. Now the main objective of TV, or for people with TV, what we intend to do is to have greater virtualization of the equipment, greater virtualization of the functions that are used, because everything today is specific to be used in broadcast, now to use it within the studio. So with IP, in addition to having flexibility, you can go toward the transformation of this hardware in software, and you can have virtual environments, and you will be able to work with services or on the cloud, service on demand, and therefore the system will be more efficient. For you to have an idea, most of the TV networks have this problem. The installation is for the peak of production. I will give you an example that I see. Fox is installed to broadcast the NFL, American football, that takes place on Sundays and throughout the year. Now here in this event, they have 100% of the usage of all of their equipment. This is on Sunday. Now on Monday, this usage drops significantly. So therefore, a great part of your equipment are idle. I believe like 30% of usage during the week. So this is not efficient. The idea to virtualize and to work with services is very important. And now for this to happen,
it is necessary that we comply with standards for media connections. There are some standards dating back from 2008. This is the SDI actually. That is a serial digital interface to television usage. They use coaxial cables. To the IP world, there are some standards. The 2022 is highly used, but not efficient because it maps the FDI and they repackage that in FDA. You have audio and video, everything packed within the IP address. That is not always enough. You just want to send an audio and you have to remove the video or to send the video throughout that sound speaker. Sony has its own standard where audio and video are packaged with different headers, and they are just a flow to different types of media. There is another manufacturer who's got a format similar to PEG-TS and PEG-TS. Different formats which may hinder you deploying an installation with so many manufacturers. So be careful if they do not comply with the same standards. That will not be possible. ING's Alliance for IP Media Solutions. Such an alliance try to standardize some of those patterns where several providers, several manufacturers, they got together to develop a format that could be used by everyone, from left to right, all those previous existing standards that could hinder the IP evolution. And on the right, we have the SPTA 2110. That is the chosen standard to become a standard by all manufacturers in all installations. Most of them are UDP, RTP standards, independent sizes, and multicast in the studio. This is the 2021-10 standard, where we have a flow for video, another one for audio, actually several flows for audios. They are all isolated with their IPs and data flow. And in the video, there is a rate reduction where the only part where there is video is broadcasted. Video at the SDI has some intervals that were reduced with this new standard, the mutual standard. There is an international exhibition fair, IBC, where the lower flows, 95% of our standards, they have already been published by the SMPT Society. That is a society which encompasses television and cinema. We have here, let's say that I want to remove a Sony camera and replace it by a Panasonic one. You can do that and without any interruption. It has to be just plug and play as it should be. And some other standards for cloud use and virtualization. That is ongoing. We still haven't got a final date, but that is our ultimately goal. All Ethernet RTP standards are used as part of the status. Any other layers were developed exclusively for TV use. So the precision time protocol was published. Media is 2110. Media description with the descriptive articles. And as to the network, the registry and equipment occupation, they all have to comply with the IS-04 to provide connection between a source and a destination. IS-05 is the standard. And as far as network control, we have definite networks by software. All those ISs, they are APIs of standardization. We have also to standardize that Italia. When the camera goes to the side, there is a red light on. Today we use a pair of cables to carry out this signaling. 1020 is 2110 is almost 100% published. /10 worries about synchronization with the 2059 /20. Here we are talking about no compression video, where those rates of 6 or 12 gigas, there is no compression so far. And usually within a studio, we do not use compression. /21 deals with the shape, the pace, the rhythm of the beats, classifying different equipments between those which are narrow or those which are broader, and the beat paces will follow that, and they are classified as being wider or narrow equipments type. All standards are respected sometimes, and they do not work because there are some bursts or because they are generated by a software, and the equipment that is receiving, if in that case that is a narrow one, it will not be able to get it as some buffers have to be conducted. Then we have subtitles, time codes, several other aspects which have to do with video production, and we cannot deny them. /8 is an integration of the previous one, 2110, and the last one, which has not been published yet, that is a support for compressed audio and video. That is a light, a mild compression, 3 to 4 times low latency to be able to be performed within the studio setting. There are several other standards that are being studied for further recommendation. As to synchrony and timing, we work with synchrony generators which exchange messages to all other equipments in the network, where all equipments can be synchronized with a difference of microseconds between one and another. When you turn on the equipment, there is a great chance to be out of time in relation to the master time. 4 messages are exchanged with receptors. Receptors will keep those sync messages, and after some time, they can know the shift in relation to the master. And in addition to the shift which is corrected, still they have to comply with a network delay which has to be calculated. And after the 4th message, you may synchronize that. All these messages by default, they take up to 5 seconds after the synchrony, and then there is a precision of accuracy of microseconds. We have to have cameras or image sources that are connected at the network, which produces the multicast flow. They have to be acknowledged by the broadcast controller, which is the connection controller available in a broadcaster. And with that, you have a connection, and the media is broadcasted from the source to the receptor. That can easily happen when you try to have different suppliers, different vendors. And if there is no standardization, the source cannot register in the network, and the network will not be aware about the existence of that equipment, and connection will not happen. But if you have some sort of standardization, service provider, when you connect a camera, they register, well, hello, I'm a camera, I have a video flow, one of audio or 2 videos, I need a return. They register, and from them on, they can, throughout a different API interface, to conduct the connection with that source, acting the multicast of that source, and even with different vendors, they can make receptors being able to connect to the proper flow. And with that, there is interoperability among several vendors. You can have a band control that allows a very interesting control to your network using those protocols such as metconf or openflow or any other specific protocol or of any other manufacturer, where you can have a great control accuracy of the network. That's interesting for security. No other bit will transit into the network if that is not authorized. Similarly, we have a register provider, and throughout an API interface with a SDN controller, the broadcaster of the equipments, they can establish those desired connections, where they establish what will be the connection from point A to point B. They establish the connection like that. Can we work with 21 then without those interfaces? And some of the broadcasters, they use that, and they are committed to develop specific drivers to each equipment. There are several equipments from different manufacturers where you have to control the communication drivers with each one of the equipments, identifying each required driver. That is part of the installation process, and there is a risk of manufacturer invalidate the driver. That's possible. Those of you that could not wait and installed it not according to the recommendations, you are working but with some restricted conditions. That's very worksome. There is sound. That's a quite didactic video. Well, I'm so sorry. That was a demo, a graph of a remote production. That was a graph showing a remote production. You have the studio can be 100 meters or 100,000 meters, doesn't matter, allowing remote production. That was a theater with a remote production where the team goes to the gig, to the event, they travel, and the team which is within the studio can be shared after that event to another one. That is the idea of remote production. That's it for now. Thank you. Questions? The idea with this presentation was exactly to go out of the box, allowing you to make some considerations. It's low latency, high velocity, the little jitter. Some tests they started to be done for remote production, and that will be a trend. I guess the broadcasters they will start using this type of connections for distant connections. Several companies are working with that, especially sport broadcasters. They are working a lot with that configuration of remote connection. Okay, thank you.